So now let's go over the reviews of the derivative techniques. So this is the reviews of differentiation of the derivatives. So so what are the major results we have? We first have the what we call the sum or difference rule. So for example, so problem like this. Yeah, so like when you have a sum fx plus gx, so if you want to take the derivative of that, and we know that this is simply fx derivative f prime x plus g prime x. Okay, so we take the derivatives of them separately, and even it works for them. If you have minus sign, it's a minus sign. So let's look at an example of this type. So let's say find dy by dx if the first one is this y equal, so let's say x to the 7 plus square root 7x minus 1 over pi plus 1, something like that. So if you have this one, you can see there are three terms, so you take the derivative one by one. So so that means you're gonna say dy by dx, which is simply 7 x to the 6th by using the power rule. We know the power rule. What's the power rule? D by dx, x to the n is simply n x n minus 1. Okay, so yeah, very good. And then so what also we have is so we can say this is what we normally call the power rule. Yeah, what do I like books on it. Okay, and then so from that we can say n x n6 and plus square root 7, and then you say that x means x to the 1, so it is so what do you get? So you get 1 x 1 minus 1, and then minus, this is a constant, so when you have a constant, you get the derivative 0. Okay, so 1 to the 1 means 0, 6 to 0 means 1. That means your final answer would be 7x to the 6th plus square root 7. So that's the answer for the first question. So let's do the second question. How about, okay, so and then what's the next result? So I'm gonna go with the next result. So the next result is the product rule. So what's the product rule? So the product rule is, let's write it. So the product rule is, we have a product what we call u and v, and then we take the derivative of that, so it is uv prime plus vu prime. So uv prime vu prime, and it comes with a plus sign. So let's do a problem from that. So the second example, I'm going to do y equal x plus 1 square, and then x squared plus 2x, okay, something like that. So and you can see that this is the u function, that is the v function. So that means y prime is simply uv prime vu prime. So u, that means x plus 1 squared, that's u, and then v prime, we take the derivative of the v function, so you get 2x plus 2, and then now what we do, we can leave with the v, that means x squared plus 2x, and then we try to take the derivative of the other one. If you take the derivative of v, if we take the derivative of u, it is 2 x plus 1 to the 1 times 1. Okay, now what we try to do, we try to get the common factors out. So that's the kind of easiest way to simplify these kind of things. So you can see you can take the 2 out here, so you get 2 out, so you're going to get x plus 1, squared, and another x squared, so x plus 1 cube, and then we have x squared, plus 2x, and here so we already have 2 out, so it is x plus 1. So what you can do, you can take 2x plus 1 out as a factor, then you're gonna get x plus 1 squared plus x squared plus 2x. So what you can do is you can simplify inside, so 2 x plus 1, and then if you expand, this is x squared plus 2x plus 1, and we have x squared plus 2x. So if you combine, you're gonna get 2 x plus 1, and then we have 2x squared plus 4x plus 1. So that's the final answer for that. Okay, so that's the product rule. So what's the product rule? uv prime plus vu prime, and this has a plus sign. So let's go to the next major result. That's the quotient rule. So what's the quotient rule? When you have a u and v, take the derivative, so it is v u prime minus u v prime over v squared. That's the quotient rule. What's the easiest way to remember? V is in the bottom and v comes first, so that's the easy way to remember that. So v gonna comes first and then u. Okay, v comes first, not u. That's how you remember. So yeah, so let's do an example from that. So let's example number 3. Let's do this problem. Let's say is equal square root t over 1 plus square root t. How about that? Yeah, so this is like good one for, so you can see this u function, the v function. So ds over dt is v, so it's a 1 plus square root t v, and then u prime, so u prime minus u v prime over v squared, so 1 plus square root t squared. So now let's try to find them. So 1 plus square root t, and then take the derivative. So this is t square root, means t to the 1/2. So if you take the derivative, it is 1/2 t negative 1/2 minus square root t. Same thing, because if you take the derivative 1 is 0, so you get the same thing here. So 1/2 t to the negative 1/2, okay, divided by 1 plus t square root whole thing squared. Let's try to simplify this a little bit, and then you can see that t square root 1/2 is common, so you can see this part is common. So I'm going to take it out and bring it down. So negative 1/2 means positive 1/2, you go to the down, so that means you can rewrite this part like this. So you can say 1 plus square root t coming from the first term minus square root negative t coming from the second term, and then I'm going to move the 1/2 t to the negative 1/2 down. So that means you're going to get 2 square root t 1 plus square root t squared. Is that clear? Because 1/2 t to the negative 1/2 means 1 over 2 square root t. So that's why. Now you can see in the top, this and that get cancelled, so you only get 1. So that means your final answer is 1 over 2 square root t 1 plus square root t whole thing squared. So that's much better. I mean, you can expand it, but you can also leave it like that. So it's okay. Or you can just span the bottom and then multiply by square root t. So that's another way to write this. So so both are okay. Okay, so let's do another problem from then the next important formula is the chain rule. We have already used the chain rule in several situations. So the chain rule, this is the most important one for Calc 2. Okay, so most of the formula depend on the chain rule, the backward of chain rule. So what's the chain rule? So this is like when you have a function of a function, so right, composite functions. That's when we use the chain rule. So we have like y equal fx and inside another function, so fx to something like that. So these kind of situations. So it's a function of a function. So in general you can say so you have a so I'm gonna like erase this and write it like this. Is much better. So we can say you have a function of this form. You have a function, but that function is another function of another. Okay, so you have function, but it's a function of another function u. So in that case, and the u is also a function of x. So u is a function of x, and f is a function of u. Now the question is, what is dy by dx? So it is simply, we know that what you're trying to do is we're gonna take the derivative of f with respect to u first, and then multiply by du over dx. Okay, so that is the chain rule formula. So just to recall, let's just do easy one first. So let's try to find the derivative of x cube plus 1 to the 5th power. Okay, so here you can see that the u function is the one inside, so that's the u function. That's the u function. So this is almost looks like u to the 5th. Okay, so that means if you take the derivative, of this one, what's gonna happen? So what you're trying to do, so I'm gonna rewrite it like this, because otherwise it can confuse you. So this looks like this looks like d by dx u to the 5th. That's what it looks like. Okay, so according to the formula, what it says, if you see something like that, you're gonna take the derivative with respect to u first. That means 5 u to the 4th, but you still need to multiply by the derivative of u, so you have du by dx. So that's what the formula says. According to that, what you get, it is 5 u means x3 plus 1 to the 4th power, and then multiply by the derivative of the inside function, that is 3x squared. So it would be better to simplify, so you get 15 x squared x cube plus 1 to the 4th power. So that's the derivative. So this is very, very useful in Calc 2, this technique. Okay, so this is the most important technique for calculus 2, the chain rule. So we use the chain rule a lot. So it's a good idea to understand these kind of questions and make sure that you kind of go over this one quickly and try to understand it. So let's try to do a couple of examples. Because of that, we already did one example, the derivative of x3 plus 1 to the 5th power. So let's do more. How about I don't want to do like too complicated one, but it's like little complicated one. So how about this one, number 5 actually. So let's do number 5. Number 4 was the one we just did. So how about this one? We say s equal secant t plus tan t to the 5th power. So it's a very similar situation. So it is ds over dt. So we're gonna first consider, we just consider the inside function is simply a just single function. So if you consider this as a single function, your derivative will be 5 whatever, we don't change it, just leave it like that, tan t to the 4th power. So we just create the inside function as just x and then multiply by the derivative of the inside function. So we multiply the derivative of the inside function. So secant t plus tan t. Okay, so let's do that. So it is 5 secant t plus tan t to the 4th power. So multiply the derivative now. What's the derivative of secant? Can you remember what's the derivative of secant? So derivative of secant is secant tan. This is secant and tan. What's the derivative of tan? Derivative of tan is secant squared. Okay, so that's what you get. And you can also take the common factors, and you can see that the secant is a common factor. So right, so the secant is a common factor, so I'm going to take it out. Once you take it out, you get a secant tan term, so that means you can combine with that. So you get 5. I'm going to take the secant term out, and then you're going to get secant t plus tan t. There are 4, but you get 1 more here, so you get 5. So that's the answer. So it's a 5 secant t plus tan t to the 5th power. You always need to simplify these. Okay, so it's make sure that you simplify them. Is it clear now? So we use the chain rule. Okay, so it's a chain rule. Chain rule. Okay, so let's do more. How about this one? So let's say y equal to sine squared x minus or plus, it doesn't matter, tan squared x. Okay, so anyone want to try this? You can stop the video and you can try first, and then you can compare. That may be the best way to do questions like this. Again, you have to use a chain rule. So it's a dy by dx. First create sine x as just x. So if it is x, then you're going to get 2 comes out, so that can become 4. So 2 times 2 sine x, and then you multiply by the derivative of the inside function. In this case, inside function is sine, so derivative of that is cosine x. Okay, so that's the derivative of the first one. What's the second one? 2. You consider tan x is just x, so that we get 2 tan x. Okay, because you just treat this as like x squared. If x squared, 2x. That's why you get 2 tan x. Because tan is like x. Then you need to multiply by the derivative of tan. Derivative of tan is secant squared x. Okay. We can simplify this. I can't do much here, but you can combine these because 2 sine x cosine x is simply equal to sine 2x. So that is a trigonometric formula. So that means become 2 sine 2x minus 2 tan x secant squared x. So that's the answer. How about this one? So y equal to theta sine theta square root. So this is like, what is this? 2 theta sine theta 1/2, right? So 2 theta sine theta acting like x, so that means again using the chain rule. Is with respect to theta. Okay, it's chain rule 1/2. 2 theta sine theta negative 1/2 just using the power rule, and then multiply by the derivative of the inside function. So what's inside function here? 2 theta sine theta. So that's a product, so you have the product rule here. So let's use the product rule. So you're gonna get what do you get? So it is 1/2 2 theta sine theta negative 1/2, and then multiply by the derivative. Use the product rule. I'm going to consider 2 theta as u, sine theta as v. So if you do that, take the derivative of the first one, so you're gonna get 2 times sine theta plus now you multiply the derivative of the second one, 2 theta, derivative of sine theta means cosine theta. See whether you can simplify. You can't do much, you can just take the 2 out. Once you take the 2 out, and with 1/2 it get cancelled. So that means your final answer become sine theta plus theta cosine theta divided by 2 theta sine theta square root. Okay, so that's what you get. Good. So maybe just 2 more examples, and then that will be enough. So you can see that the chain rule is the most important, because we're going to use this a lot in the rest of the course. Okay, so please spend more time to understand the chain rule. That's pretty much the how the integral works most of the time. So I'm going to do 2 more examples. So what was the number here? 7. So let's do 8. How about this one? Y equal 10 e to the negative x to the 5th. What do you know about e to the x? E to the x is when you have a function e to the x, the derivative of e to the x. So when you have a function e to some function, so what happened by the chain rule, it is e to the fx, and you multiply by the derivative of that function. Okay, so those are the 2 major results. And then also if we have a to the fx, a is a like some other base than e, what happened is a to the fx, and you have to multiply by ln a, so that then we have prime x, and you also have that extra it looks weird. So we have f prime x, and then you have ln a, so that's what you have the ln a term. That's the extra term coming here if you have a base, something other than e, because we know that ln e equal 1, so that can go away. So those are 3 formulas related to the exponential function. Ex is ex, and then e to the fx is e to the fx times f prime x. A to the fx is a to the fx, and f prime x f prime x ln x. I'm sorry, ln a. Okay, so let's use that here. So we have dy by dx. This is chain rule actually. So what do you get? You get 10 e, no changes, and then you multiply by the derivative of the top function. So derivative of the top function is derivative of minus x to the 5th, so which is simply negative 1/5. So that means 10 e negative x 5th times negative 1/5. Right? Yeah, negative 1/5. So 5 and 10 get cancelled, so you're gonna get negative 2 e negative x 5th. And then the number 9 is let's do just one more. That's enough. So y equal 1/4 x e to the something 4x, and then minus 16 e 4x. I think this will be easy for you. You want to try it. The first here is a product rule, and then you have the chain rule. So it's a dy by dx. If you use a product rule, you can write 1/4 out. You don't want to get confused with that. And then just use the product rule. So take the derivative of the first one, multiply by the second one, plus first one multiply by the derivative of the second one. So 4e 4x. Okay. You know that there are no change to the exponent. 4x goes like that, and then that's done. And then minus 1 6 16. So take the derivative of 4e 4x. You can do it like, oh, you can actually simplify first and then do it. So that's another way to do it. Yeah. So what do you get? So you get you can see there's a nice simplification here. It's 4 and that 16 get cancelled. You get 4. So you have 1/4 e to the 4x, 1/4 e to the 4 is plus. So that means this whole thing get cancels with that. So you finally end up getting and then also the 4 get cancelled later. So this 4 and that 4 get cancelled later. So that means you end up getting that's the second step. So you end up getting simply x e to the 4x. Okay. So now, yeah, so this is like a really nice question. Later we come to this problem, because you know that so once you take the derivative, you get x e 4x. Now we have a question. We know that the relation between the integral and the derivative is the inverse. That's means if you take a, so let's say you have a function, and if you take a derivative, you get that. Now if you take the integral, you come back. Okay. So that's the idea. So that means according to this result, what you can write? You can write the integral of x e 4x is simply, because once you take the derivative, is the other one. So that's 1/4 x e 4x minus 116 e to the 4x. We know that when you have, we know the most general antiderivative, this is what we call antiderivative, you can add a plus c. So we have this result. Okay, that's a huge expression, but can you guess that? That's not easy to guess, but we have a technique. Okay, so we discuss a technique that we call integration by parts. Integration by parts. So what we call IBP. So this is a like special technique. We can discuss that in one section, and then we're gonna do like maybe like a lot of examples, because this is like very important technique that we use like pretty much everywhere. This is called integration by part technique. But you can see we already know like how we get that, but we can discuss that later, where this is coming from. So it's coming from integration by parts, but that's a like different section. We're gonna do the third week. You can see we have to wait long, because this is like a major technique. It takes time to understand. Okay, so it's called integration by parts technique. Okay, so that's enough for derivatives, and make sure that you go over them and completely understand, because we can use them here and there in other problems. Okay, so thank you so much. This is the end of derivatives. Okay, so end of derivatives. Good.